So, good afternoon, everyone. I'm Anurag, working at Planview, and the product I work on is a social collaboration tool called Project Place. So, during the last year's event, we got exposed to a lot of brilliant ideas and experiences shared in various talks. And in last 1 year, had opportunity to try some of them which resonated within the automation community of our organization. And as part of this talk, I would like to share our experience. So let's quickly cover the agenda for today's presentation. There are 3 sections, starting with getting the right test pyramid, using Appium for mobile automation, and using third-party infrastructure service instead of a local grid. Intention here is to demonstrate what each of these initiatives meant to us, our efforts towards making it successful, and what we have learned from them. So starting with the first section of this talk, which is getting the right test pyramid or automation test pyramid. So automated tests come in a variety of different flavors with different costs and benefits. They are sometimes called by different names by different people. So the automation test levels that we have are unit tests, integration tests, and end-to-end GUI tests. So inverted test pyramid here depicts the trend that most of our tests fall in the GUI test level. Problem with large number of GUI tests is they take a long time to execute. Our product is a cloud-based service, and at present we do weekly releases. So certifying new features and verifying that existing ones are intact takes more time with GUI tests. So with the goal of making weekly deployments and in future daily releases more effective, the idea of having unit tests, integration tests, and GUI tests in right proportion makes perfect sense. So we decided to correct the test pyramid. Yep. So here is a snapshot of how we went about achieving this goal. We started by identifying the test cases that don't require loading the complete application in browser. I have some examples in the later slides. By doing this, we realized that these test cases can be covered by faster running integration tests. So adding integration tests for us is a two-pronged strategy, where we add API integration tests for the which concentrate on the backend, and JavaScript or front-end integration tests which focus on the front-end components. And once these integration tests start materializing, replace the redundant GUI tests with faster running integration tests. One recommendation would be, if you are doing a new feature, try adding automated integration tests before you proceed to adding the automated GUI tests. So our product is based on MVC pattern, and these API integration tests help us in testing the model and controller part of the application. So for all the backend functionalities which are exposed by RESTful, either public or private APIs, we started adding the API integration tests. Here are a few details about the test framework that we have to support these API integration tests. We are a Python shop, and Python is the language which we have used for API tests. And these tests follow BDD approach, so they are not completely difficult to follow or understand to other users like product owners or managers. And Lettuce is the Python module which adds the BDD layer to the tests. And request is the HTTP library that we have used, or which the framework uses for making the API requests. So some more insight into our test strategy for adding API integration tests. So start by getting an understanding of the resource model that API exposes, HTTP methods API supports, and the parameters it accepts. Also, an API test should be able to cover a single API request or a complex API workflow. So, continuing with this strategy, inputs for an API test are HTTP method. It can be a get, post, delete, the URL of the API, the payload, which has the specific data for different API parameters which it accepts, and the authentication token. In the response that we get back from the API, in these tests, we validate the response code, the structure of the JSON, and also there are custom validations on the data which comes back as part of the response body. So take a look at how we maintain API tests. So these tests, as I mentioned, they follow BDD approach. So a feature file is a test suite. It contains number of tests or scenarios following the given, when, and then BDD syntax. Also, a scenario consists of a number of steps, and it's the step file which contains mapping of the steps and methods containing the actual test logic. So for each category or version of API, we maintain an API test class. So an API test class contains different class variables to maintain the state of the API. It has a list of API URLs. So if we have a particular version of an API feature, we will try to implement the different features or test requirements for that API in an API test class. So all the API URLs part of the particular feature are added here. And then there are different test methods which contain the execution logic and validations on the response. So these tests or test suite is part of our CI setup, and they get triggered periodically from Jenkins. And all the test results are available in the dashboard over there. And any failure gets notified through email and chat room notifications to stakeholders. Moving to the second category of integration tests, that is JavaScript or front-end integration tests. So these tests focus on the view part of your application. Front-end components that we have, for which these tests were written, are built using React.js. And since these tests only require mock JavaScript components to be loaded, they are very fast. So these tests, though similar to JavaScript unit tests, they are one level above. And instead of focusing on one component, they test them in a group and how they work together. So, a few details about the test framework we have for JavaScript integration tests. So pretty obvious, test framework is built using JavaScript. And Mocha is the test runner. Chai is the assertion library. And sign-on is another NPM module. It is used for mocking. React test utils help in rendering the component into a detached DOM node and to simulate an event dispatch on a DOM node. And Phantom.js is the headless browser, where components are loaded and tests are run. So taking an example of a feature we have developed recently, it's a commenting system with some social aspects, for example, likes. So comment can be added by any user, and other users can come and like that comment. So example of test scenarios that can be covered for this feature using front-end integration tests are, if any user comes and likes the comment, their avatar should be displayed. And when the number of avatars increase or go above 3, the latest 3 avatars should be shown. And if someone goes and clicks on the avatars, a drop list with all the users' details should be shown. So using the framework detailed in the previous slide, JavaScript components are initialized with required mock data. So an example would be to initialize this comment container or comment component with a comment text and 4 user likes for as part of the test setup. And when the actual test execution starts, we can verify that the 3 user avatars are visible as soon as the component is initialized into the DOM. And using React test utils, we can simulate a click on this avatars, and it will open up the drop list where you can verify the 4 users who have liked this comment, their details are visible. Also, you can simulate the clicking of the like button using React test utils, and this should first enable or disable the state of that like button, as well as add or remove the avatar of the user who is performing this like or choosing not to like the comment. So take a look at the test suite of integration tests for this feature. So this test suite is written following Mocha syntax. So here describe at the top defines a test suite, and an it keyword it defines a test. And then we have fixtures like before each and after each, which you can relate with JUnit or TestNG, are used either for setup or teardown. And running this entire suite of 25 plus tests, it takes less than a second. So they're pretty quick. So that's what I had for the integration tests. So moving to the second part of this presentation, which covers our experience with using Appium for mobile automation. So by now, like many of you would have attended the Appium workshop, or you already know this. So Appium is an HTTP server written in Node.js, and it can create and handle multiple WebDriver sessions. Also, Appium is architected similarly to Selenium. So Appium server receives commands and it executes them on a desired node. But instead of a desktop browser, the desired node here is running either a mobile application or a mobile browser on a mobile device. And this mobile device can be a simulator, emulator, or a physical device. So let's tackle the first question, which we had. Why should we go for mobile automation? So due to increase in the number of smartphone sales and requirement to provide best user experience to this user group, mobile first development approach is gaining importance. Also, when we look at the user data available on Google Analytics, we see that there is an increase in the number of users accessing our service from mobile browsers. Along with this, increasing number of mobile platforms and device combinations make the task of testing on mobile challenging. So we should probably go for mobile automation. And this brings us to the next question, that which tool should we use for mobile automation? So Appium has certain benefits. It is similar to Selenium, it's open source. It is cross-platform, that is, it supports iOS and Android platforms. Using Appium, test automation on native, hybrid, as well as mobile web apps is possible. Appium provides bindings for multiple languages. And Appium uses mobile JSON wire protocol, which is an extension to Selenium's JSON wire protocol used for client-server communication. So we started with this goal of, as a proof of concept, how should we demonstrate that Appium is easy to use and will bring in some benefit to our test initiative. So the test scenario that we tried with Appium is a simple login and logout scenario on our service. And same test has to be repeated on mobile and web browsers. So we chose Safari on iOS, Chrome on Android, and Firefox on Windows 7 as the combinations on which we want to run this test. And another requirement for us was to run test either locally or on Sauce Labs on the chosen mobile or web browser. So if you didn't attend the Appium workshop, Appium.io has detailed tutorials on setting up Appium on iOS and on the Android for test automation. Next, we have few slides showing some Appium-specific setup. This is in Java. So before we start with the tests, we need to start the Appium server and post the test run. Stopping the Appium server is a good practice. So these are the sample snippets to do the same. And this slide, it has a lot of code, but it shows the initialization of driver instance required to run these tests either locally or on Sauce Labs and on the desired platform and browser. So the open browser method here, it accepts the browser name and type. And so a browser name can be a mobile Safari or mobile Android, and browser type we have chosen as either local or Sauce. And the test is just a data-driven test. The scenario we have already discussed, it's a simple login and logout on our service. And just by adding more rows with the right parameters, we made the same test run on all the 6 combinations. So that went about pretty smooth, and that's what we realized, that Appium is a good tool for starting with our automation initiative on mobile for mobile browsers. And the last part of my talk, it focuses on our experience with using a third-party infrastructure service instead of a local grid. So again, let's start with why should we go for a third-party infrastructure service. So going for third-party infrastructure service saves effort spent in upgrading or maintaining the test node part of the local Selenium grid infrastructure. Our local grid currently does not support mobile automation. So idea of not maintaining the test infrastructure and growing number of tests on web and mobile made us look in this direction. So we decided to use the Sauce Lab infrastructure for this, and started with creating an account. And for this particular proof of concept, we chose to use our Smoke suite, and we decided to test the performance and stability of Smoke suite on Firefox, Chrome, and IE. So this test suite contains about 20 plus tests, and we chose to run it multiple times on source infrastructure and see that what kind of results we get. So in order to enable running this suite on third-party infrastructure, there were certain changes required in the existing framework that we have. So first task was to form the desired capabilities object, having the details of device, operating system, browser type, and the version. Next change was initializing instance of WebDriver on the third-party infrastructure and pass this WebDriver instance to your tests, which will, you don't need to make any change to that, the existing tests in the Smoke suite. And once the test run is complete, so each test, it runs as a separate test job on, say, Sauce Labs. So we need to update certain attributes once the test run is complete. If we don't do that, each test will look like an unnamed job with a question mark before it, because we have not passed the test case's name or its execution status, and we won't be able to utilize the dashboard facility that they provide. So updating the attributes as test case name and execution status is important if we want to use the dashboard provided by these services efficiently. And also, if tests are running as part of a build, updating the build details aggregates those test jobs. So if we don't provide the build name, again, they will be scattered, and we have to go, we won't be able to see them aggregated in the dashboard. So after making the framework changes, running the Smoke suite on just using one VM on the third-party infrastructure, it went about pretty smoothly. But tests started to fail when running the suite on all the VMs. Our license had 6 concurrent VMs. So when we tried to utilize all of them, these tests started failing, and they were failing in the get URL step. So we are trying to open our test application for all those tests. And it wasn't out of the 20 tests which we have, it wasn't the same test that failed in successive test runs. There was no pattern, or it was random. So couple of things that we tried, they helped us in avoiding these random failures. So one of them was increasing the timeout values. So as our test environments, they run on a server which is based somewhere in Sweden, and the source infrastructure is in North America. So increasing the timeout values helped in stabilizing these tests. Second, we suppress the resources or requests that are not necessary for test verifications. So in our application's landing page, we have an introduction video and also some images which take few seconds to load. So suppressing them, these requests, and along with that, there are some WebSocket requests and Google Analytics requests which don't affect the actual test verification we are interested in. So suppressing them reduce the overall test execution time and also stabilize the tests. So compared to local grid, running tests on third-party infrastructure has certain benefits. So for each test job, recording of the execution is available. This simplifies the debugging of failed tests. We saw an overall saving in the execution time, or the execution time came down from 25 minutes to 16 minutes when we utilized the 6 concurrent VMs on source infrastructure. And since each test runs in a freshly booted VM, it avoids test failures due to node hardware issues. So in your local grid infrastructure, there might be sometimes issues in the nodes which shows false positives. Also, getting extra machines as part of your subscription on any of the third-party infrastructure service is simpler than adding new machines to your local test infrastructure. So it's easier and faster to scale on third-party infrastructure when needed. One caveat, which I mentioned earlier also, network requests are much faster in local grid compared to third-party infrastructure. So in the end, I would like to summarize what we have learned working on these 3 initiatives. So by attempting to correct the test pyramid, we ended up learning importance of faster running integration tests. Adopting Appium provided our automation initiative ability to run tests on mobile platforms and browsers. And using third-party infrastructure service instead of local grid reduce the overall execution time and save effort spent maintaining the test nodes. So that brings to the end of what I have planned for this presentation. If you have any questions, maybe now or later you can ask me. Thank you.